I'm going to show you how to do a full-on linear programming problem. This one is about a Maple store that sells both printers and computers. They tell you the size of the computers are shipped in 12 cubic foot boxes and printers in 8 cubic foot boxes. And then look at this. The storeroom can hold 48 cubic feet. So it kind of seems to me like those might all go together. And then there's this other information about a sales goal, and you need to sell at least 100 computers, at least 150 printers. And then it goes on, and now it starts talking about money. So computers are sold for this much profit, and printers are sold for this much profit. And then it says we're trying to maximize profit. So here's what I think. X could be the number of computers that we're going to sell, and Y is the number of printers. I believe that there is going to be a constraint inequality that 12 cubic feet for each computer and 8 cubic feet for each printer has to fit in a storeroom that is not going to get any bigger than 4,800 cubic feet. So that is the limit. So it has to be less than that. Then there is an individual goal for computers. Computers, we need to sell at least 100 of those. And printers, we have to sell at least 150 of those. And then finally, there is an objective function. We are trying to maximize profit, and we are going to make $1,000 of profit on each computer. That seems like maybe that's a little much. And $350 for each printer. Okay, so now we need to start graphing. This first equation, we're going to find the intercepts. And let's move this over a little bit so that we can, ooh, that's not going to work at all. That's not how we're going to do it. Okay, so what we're going to do is we are going to cover up the 8y. Oh, that is weird. Okay, that's not what I want either. Sorry. We'll just do it over here. So 4,800 divided by 12 is going to give us the x-intercept, and that is 400. And I'm going to count 2, 4, 6, 8. So 100, 200, 300, 400. That would be 800 and 1,000 if we need it. And then we're going to go 4,800 divided by 8. And that gives us 600. So 1, 2, 3, 4, 5, 600 for our y-intercept. And then we can connect them. Okay, now we're going to test. 0, 0 is our test point. And when we put 0 in for x and 0 in for y, what we get is 0 is less than or equal to 4,800. Is that true? Yes. 0 is less than 4,800. So that means that all of these work. Happy face. And that means we're going to shade out. Let's do this. We are going to shade out the points that don't work. We don't need those. Okay. Then we're going to move on to these. This is a vertical line going through 100 on the x-axis. We want the x's that are greater than 100. Those are over here. So we are going to shade out the ones that are smaller. Those will not meet our sales goal. Get rid of that for a second. Okay, then we're going to take the y's that are greater than 150. So 150 would be here. And we want the y's that are greater than or equal to, those are above that line. So we are going to shade out the things that are not bigger than 150, which are all below. And what we're left with is our constraint inequality with a vertex point, and a third vertex point. One of those points is going to maximize our profit equation. Let's start with the easiest one. This one is on the vertical line that goes through 100 on the x-axis and the horizontal line that goes through 150 on the y-axis, so that's 100, 150. This point is also on the horizontal line, which means that for sure the y coordinate of that point is 150. Now to figure out the other one, we're going to take 12x plus 8 times 150 equals 4,800. Okay, so then actually I need to get a calculator because I'm just not going to do that in my head. And then you can see what I'm doing too. Let's get rid of all this stuff. So 4,800 minus 8 times 150 is 3,600 divided by 12 leaves 300. So this must be the point 300, 150. We're going to do the same thing for this one. This one is on the vertical line going through 100, so that means that must be the x-intercept, or the x-coordinate. We don't know the other one. So, ooh, sorry about that. Okay, we're back. So then, 12 times 100 plus 8y must be equal to 4,800. Sorry, that's getting so squishy. We'll bring in our calculator again and figure out that 4,800 minus 12 times 100 is 3,600 again, but this time divided by 8 gives us 450. Those are our vertices. Now, the next thing we're going to do is put those vertices in our list. This is, I think, the most clever way of doing it. So first I'm going to clear my lists. And we'll move over. Okay, so our x coordinates are 100, another 100, and the third coordinate has 300 as its x. Next to them, we're going to put the y's. One point is 100, 150. Another point is 100, 450. And the third point, its y coordinate is 150. Now if you look, these are the coordinates that we just figured out. What we're going to do is we are going to use the profit equation right here. And we are going to take 1,000 times each x, which are listed in list 1, and 350 times each y, our y's are in list 2, and figure out our profits. So we're almost done here, so hang in here. Go all the way up so that your cursor is on the name of list 3. Take 1,000 times, you don't actually have to hit times, list 1, second 1, plus 350 times, although you don't really need to hit that, list 2, second 2, and hit enter. Here are all our profits. You kind of scan through, find the biggest one. That would be 352,500,000. So then you would write that out as a sentence. 352,500. I have to remember that. Okay, so write this. You should sell. Let's see. Now I've forgotten. This many computers and this many printers for a maximum profit of blank. Now, let me bring up the calculator so we can remember what those numbers are supposed to be. They are supposed to be 300 and 150, so 300 and 150. Let's check again. And 352,500. 352,500. that's not 3 million. 352,500 is your maximum profit. You always finish one of these problems with a complete sentence, and we are done.